Welcome back, everyone. In this video, we're going to be talking about the difference between distance and displacement. We talked about distance traveled in the last video, and that is how much ground an object is covered, whereas displacement is the object's overall change of position. And at first glance, these sound like these are always going to be the same, which is true if the object is only moving forward. But if the object happens to move backwards at any time, you're going to get different answers for distance and displacement. Because whether you move forwards or backwards, that's always going to add to the distance. Like if you run 5 miles one direction and turn around and run 5 miles backwards, that you ran 10 miles. Whereas with displacement being the overall change of position, if you run 5 miles forward and 5 miles backwards, right back to where you started, the displacement is going to be 0 because your position at the end is no different from your position at the beginning. For a more hands-on example, let's say that we have a particle that moves forward along a straight line at 30 centimeters per second for 5 seconds. It then moves backwards at 10 centimeters per second for another 5 seconds. And the distance traveled here is the distance moved forward plus the distance moved backwards. So the distance moving forward is 30 times 5 because that's the velocity times the time. And then we're going to add the movement backwards, which is 10 times 5. And if you add those together, you get 200 centimeters. Now for displacement, we have to take the forward distance and subtract the backwards distance to figure out where this particle ends compared to where it started. So we're going to take 30 times 5 and then subtract the backwards movement, which was 10 times 5, to get 100 centimeters. So the displacement of this particle is 100 centimeters, whereas the distance it traveled was 200 centimeters. And much like the last video, we're now going to look at this graphically to see what's going on here. And this function in red represents the velocity of this particle over time. For the first 5 seconds, it's going 30 centimeters per second, and for the next 5 seconds, it's going negative 10 centimeters per second, and that's why it's below the x-axis, because the velocity is negative. And just like in the last video, I can represent the distance traveled as the area of a rectangle. And so this first rectangle has a width of 5 and a height of 30, and the next rectangle also has a width of 5 and a height of 10. And when computing the distance traveled, we add these areas together, but when we're computing the displacement, we take the area above the x-axis and subtract away the area below the x-axis, and so that area below counts as negative. And so while we usually think of area as always being positive, when computing the displacement, we have to count that area below the x-axis as negative. And just so you have it in writing, the distance traveled is given by the area above the x-axis plus the area below the x-axis, whereas displacement is given by the area above the x-axis minus the area below the x-axis. Because once again, the area below the x-axis represents the particle or any object moving backwards, and so we have to subtract that area.